Hello! In the last video, we had occasion to draw a distinction between a sample and a population. We made the point that the former is a subset of the latter. The question that arises, however, is how a researcher can accurately produce a sample that represents the population. The process whereby a researcher decides to draw a sample from a population is referred to as a sampling technique. There are generally two types of sampling techniques: probability sampling techniques, also known as random sampling techniques, and non-probability sampling techniques. In this video, we'll discuss a number of random sampling or probability sampling techniques, and we defer our discussion of non-probability sampling techniques to our next video. We will discuss simple random sampling, stratified sampling, systematic sampling, and cluster sampling. Simple random sampling is a technique that ensures that every single member of the population stands a chance for being represented in the sample. This means that there are no a priori criteria, no a priori decision made on the part of the researcher. As an illustration, let's imagine that our population consists of 1,000 students. And from this population, we are interested in a sample of 100 students. What we can do is list the 1,000, for example, if we have access to a database, or if we can list the students in one way or another, and then use a random number generator software, like for example Excel, or there might be applications, and we ask the software to generate 100 unique numbers from 1 to 1,000. The software generates 100 numbers, for example, 7, 22, and 103, 200, 201, 303, 304, 307, 363, 408, and so forth. I take those numbers and I go to the list and select the cases that correspond to those numbers. The second probability sampling technique is referred to as stratified sampling. Stratified comes from stratum or strata, which means layers. Here, the researcher decides to divide the population into subgroups. Maybe the division can be made based on age or on gender or on other characteristics in order to ensure that every segment of the population is represented. The researcher can decide beforehand, for example, to have 50% males, 50% females, or if we have more than two categories, then we can have, for example, let's take age, 20% of people aged between 15 and 20, and another 20% aged between 20 and 25, and then etc. And so we have 20% from each segment. This way, the researcher ensures that his sample has more credibility, has more representativity. And now we move to the third type of random sampling or probability sampling, systematic sampling. The researcher, for example, can decide to take every fifth student. This is systematic. The researcher can count 1, 2, 3, 4. The fifth element is taken. Let's say the fifth student is taken. And then they start again. 6, 7, 8, 9, 10. They take the 10th. And so on and so forth until they have a sample of, 20, or depends on the targeted sample. The last probability or random sampling technique to discuss is what we call cluster sampling. In cluster sampling, the researcher generally divides the population into segments known as clusters. The researcher divides the population into segments known as clusters, and they randomly select from these groups to form a sample. Here is an example. Some students might choose, for example, to study a behavior among Moroccan higher education students. So what these students do is choose one university in the north, one in the middle of the country, and one in the south of the country. And of course, they random sample from each university. This is what we call cluster sampling. Cluster sampling should not be confused with stratified sampling. In cluster sampling, the groups are heterogeneous. They are not sorted out based on age, gender, or no. But in stratified sampling, the decision is made, for example, to choose certain characteristics in every group. Thank you.